家在叫的哦，要是。你把那个音一直帮我调负2.7啊，整个会偏暗。你把我这个调到负2.7啊，好像是很暗的，是这样子，害死。
So good morning, ladies and gentlemen. Good morning, ladies and gentlemen. May I have your attention, please? Today's first presentation session will begin shortly. Please have a seat as soon as possible to ensure a smooth start. We appreciate your cooperation. May I have your attention, please? Today's first presentation session will begin shortly, so please have a seat as soon as possible to ensure a smooth start. We appreciate your cooperation. May I have your attention, please? The first presentation session will begin shortly. Please have a seat as soon as possible to ensure a smooth start. We appreciate your cooperation.
尽量不要看手机，如果开始的话，不然会错过。因为它这是有国际性的，所以要帮你一下。好，先切回来。
Honored guests, presentation teams, working students, we hope you are feeling well rested. Session promises exciting presentations that will undoubtedly spark your imagination, ignite your quest for knowledge. So get ready for an exciting journey. Before we begin, please note that each team has 10 minutes to showcase your ideas. Our staff will hold a play card to remind you of the time, 3 minutes and 1 minute before your time is up. When you read the play card showing time is up, please finish your presentation immediately. The microphone will be turned off at the same time. 3 honorable commentators are joining us today. They will provide constructive feedback after the presentations. Please join me in welcoming them. First, Dr. Cai Chun Li from National Chen Kung University. Thank you. Also from National Chen Kung University, Dr. Shi Quanfeng. Next one, Dr. Du Yiqun from National Chen Kung University. So now let's get started. Please welcome the first team. It's our first time to have students from Australia, students from Haileybury College, who speak upon has the Australian under-16 social media ban been effective. Please welcome the team with a big round of applause.
Lão师们、同学们，大家好，我叫林迪。我是 Nuki。
皆さん、おはようございます。私はアリアナです。
Good morning, my name is Sophie, and we would like to welcome you to our presentation on the under-16 social media ban in Australia.
When Australia first implemented the social media ban for people aged under 16 years old in December of 2025, it changed things for us and created a global discussion. Now, countries like the UK, France, and Spain are considering similar policies. There are an estimated 4.7 million teenagers below 16 in Australia, yet 80% of them have not been affected by the ban and can still easily access social media. This discrepancy between the law and reality is exactly why we wanted to study just how effective this ban really is. Does it truly protect the well-being of young people or only address surface-level symptoms of a much deeper issue. To find out, we completed a detailed study across our 4 school campuses.
Our research was guided by 3 main questions. 1. Does the digital education provided by schools adequately address the needs of young people? 2. Does a blanket social media ban effectively address the underlying issues that it was introduced to resolve? 3. In what ways are young people impacted by this ban, and how do they perceive and respond to it? As students, we were interested in understanding whether our community believed that the ban could improve their online safety and well-being, or whether it considered only surface-level challenges.
In order to collect both quantitative and qualitative data, we conducted surveys for years 7 to 12 students and teachers from various departments, allowing us to gather diverse types of data. Overall, we received 383 student survey responses and 27 teacher survey responses. We also conducted detailed interviews with teachers who are in positions that are closely aligned with student needs and concerns. We found it somewhat challenging to choose a topic, given our different perspectives and opinions, and the large variety of potential issues such as AI and overall mental health. However, we ultimately decided that the under-16 social media ban provided an opportunity for a timelier and more Australia-centred investigation. During our research, we also received several irrelevant and invalid responses that needed to be filtered, as they did not provide meaningful input into our research.
Such a topic was chosen due to its current significance both upon a local and global stage. However, due to the manner of data collection through surveys, certain difficulty was encountered when sifting through hundreds of extensive responses, specifically in finding information that was relevant to the investigation. We were able to manually clean the data and remove invalid responses using a set criterion to determine a response with utility to our research. We noted long answer responses in which the student or teacher provided nuanced depth, and whilst also recording shorter responses that indicated a clear, more obvious stance, including them in our consensus data to maintain a broad statistical representation without compromising the quality of our qualitative evidence. For context, social media has been around for 30 years and still remains a focal point of the 21st century. It's estimated that 93% of adolescents use social media daily, which I'm sure comes as no surprise to any of you. However, concurrent to this rapid rise in usage, concerns regarding the mental health, safety, and cyberbullying of young people on social media have also increased.
We surveyed 383 students across our cohort from the 7th grade to the 12th grade, covering ages of 12 to 18 years old. We found that on average, the majority use social media between 1 to 2 hours per day, only slightly lower than the global average of 2 hours and 4 minutes. Within this same pool of students, social media use was primarily spent on YouTube at 31%, Instagram at 21%, TikTok at 19%, and Snapchat at 19%, all of which should have been banned for under-16s usage.
Having concurrently surveyed 27 teachers from across a wide range of subjects, we noticed a stark contradiction between both students and teacher viewpoints. When asked to rate the ban's effectiveness on a scale of 1 to 10, the average student response was 2.9 out of 10, whilst the average teacher response was 8.3 out of 10, indicating a clear difference in perception of the ban. The under-16 social media ban came into effect on the 10th of December 2025, and by May of 2026, 79% of students under 16 had not been banned from social media apps. This falls slightly below the greater Australian average, in which it was found that 85% of under 16s were not banned from these apps.
A common theme across the students surveyed was that most did not believe that the social media ban was effective. Many explained that people under 16 could still easily bypass the restrictions and continue using social media. Whilst some agreed that the ban had good intentions and could be beneficial in theory, they felt that it was not being effectively enforced in practice. Student responses indicated a clear acknowledgement of good intention, however consistently point towards the ban being ineffective and inadequate. Overall, student sentiments towards the ban pointed towards a failure to address the root causes of online harm, simultaneously denoting the ban as placing too much focus on restricting access rather than encouraging responsible online behaviour. Teacher surveys primarily suggested a preference for theoretical support of the ban, however had concerns surrounding its practical enforcement.
Concerns highlighted cyberbullying, online harassment, and a decline in real-world social interaction as the two most prominent issues associated with young people's usage of social media. Additionally, only 27% of teachers reported a positive change in the classroom behaviour following the ban, with overall consensus suggesting that it had little impact in this area overall. Through our research with teachers, 81% believe the ban was effective, 19% consider it ineffective, demonstrating strong overall support for the policy.
However, there were some major concerns from the teachers. These included students bypassing the ban, the students' understanding of digital literacy, the enforcement of the ban, lack of accountability from social media companies. Many teacher responses showcased a desire to help young people's well-being on a more individual level, addressing root causes of issues rather than banning social media overall. This is furthered as many teachers specified that the ban failed to address root causes of harm, suggesting a need for more direct intervention or aid.
Ultimately, we believe that we could have improved our research by having a clearer vision of our investigation from the outset of our research. By spending more time conducting research into Australian public issues, we could have come to a timely decision on our focus of the social media ban. Additionally, we could have focused more specifically on quantitative data, as the wide array of qualitative data made it challenging to evaluate a broad consensus on the issue from both students and teachers. Finally, we could have implemented more directed questions to avoid vague feedback, especially from younger students.
We believe that this investigation could be helpful in evaluating how the Australian government might more effectively or more comprehensively promote well-being for young people. Yet our research could be furthered by conducting a study between similar nations with differing management of social media to confirm a correlation or any clear success. Another interesting exploration could be centred around the idea of digital displacement, or the idea that banned under 16s may migrate towards less regulated forums with often higher safety risks than mainstream, more regulated platforms. A longer-term extension would additionally help to determine if the ban can act to decrease rates of clinical anxiety, depression, or other mental health disorders over time, or whether this poor well-being is maintained.
Inevitably, this exploration has deepened our understanding of the gap between policy intent and real-world practice in Australia. We hope that this insight may be applicable to topics relating to AI regulation or data privacy laws. Additionally, we gained practical skills in survey logic and data management, which may be directly transferable to any future social science exploration. We believe the ban is somewhat ineffective in practice due to its issues in enforcement. However, it shows promise in the government's willingness to address problems in young people's well-being. We hope that this investigation may have exposed the challenges associated with policy development and how outcomes may differ from government expectations. Thank you.
Thank you. So the next team is from UST Angelicum College, the Philippines. They will speak upon Ally, Energy Bar from Ally Grain. Please welcome them.
Hello, hello. Okay. Before we start presenting our research presentation, I'd like to start off by asking our dearest audience a great question. Who here loves vegetables? Anyone? Wow, there's a lot. Well, if we will be completely honest, none of us three actually enjoy eating vegetables. You know, it is sometimes hard to feed vegetables, especially to kids. And this has caused a gap in the youth's nutritional health in our city. They can't just eat junk foods all day, which is why we invented a snack that is enjoyable, delicious, but most importantly, nutritious. Mabuhay mula sa perlas ng silanganan, the Philippines. I am Rain San Diego,
Saria Tienda,
and Reese Fernandez, proudly presenting our product AdLife. Live the life with AdLife. A 2023 National Nutrition Survey conducted by the Philippine Department of Science and Technology Food and Nutrition Research Institute found that nutrition gaps, weakening immunity, threatening eyesight, and affecting development remain a concern among Filipinos, particularly young children and pregnant women. This is often referred to as hidden hunger, and these gaps occur when people consume diets that lack the essential vitamins and minerals such as vitamin A and iodine. This particular survey revealed that 3 in every 100 Filipinos have vitamin A deficiency, with the highest prevalence among preschool children aged 6 months to 5 years, and the lowest among adults and older people with 0.9%. AdLife started as an idea to utilize the rich graces of an agricultural country like the Philippines. The local grain AdLife, also found in other countries of tropical Asia, was their chosen ingredient. But you may all wonder, why AdLife? Well, to start, AdLife is a locally grown grain in the Philippines known for its rich nutrient content. AdLife is also known as job steers or Chinese pearl barley, and it is a nutrient-dense grain alternative that contains potassium, iron, calcium, and fiber, while also having relatively low fat content. AdLife is also culturally relevant. The Subani tribe of Mindanao, a major island in the Philippines, call AdLife their champion crop, as they believe in the medicinal benefits from eating AdLife. They claim that their ancestors lived up to 150 years eating only AdLife porridge. This is because AdLife is grown organically with no chemical fertilizers helping it to yield. Now, as I move on to my next point, you may all also ask, what actually pushed for the innovation of the AdLife energy bar? Well, as we mentioned earlier, there is a gap in the youth's nutritional health, or what we call nutritional deficiency, in communities in Quezon City in the Philippines, with some experiencing hunger, while others consuming excessive amounts of unhealthy food, resulting in the triple burden of malnutrition, undernutrition, macronutrient deficiencies, and overweight/obesity. We meticulously chose our ingredients to ensure not just profit, but most importantly, purpose to help and benefit other people. But of course, our product was not solely made for this purpose, but also to provide an option for people who want to eat healthy and enjoy their food at the same time. With all of these in mind, AdLife Energy Bar seeks to achieve 5 main goals in response to the Sustainable Development Goals, namely SDG 2, 3, 8, 12, and social progress. First and foremost is to identify what has been the problem with Quezon City's youth nutrition, and secondly is to innovate a snack according to their needs. They are our target beneficiaries, but of course, our product is not solely for these communities, but for everybody. AdLife is our superpower to feed, benefit, and make communities healthier.
Third is to support AdLife farmers and local sources of the ingredients in creation of our AdLife Energy Bar. We bought our AdLife grains from a source who harvests grain in Bukidnon, a province in northern Mindanao, Philippines, which also serves as the region's food basket due to its massive agricultural output of rice, corn, pineapples, and sugarcane. We also made sure that the other ingredients utilized were also Philippine-made. Fourth is to use minimal and sustainable packaging for our energy bar. Of course, AdLife is also a green initiative. More than being a fruit product, its purpose is to help not just people, but but also our Mother Earth. And last but definitely not the least, is again the utilization of adlai and other ingredients for its nutritional value to help address nutritionally deficient people in Quezon City and even in some places we hope to share around the world. Now, malnutrition remains a challenge for many children in the communities of Quezon City, highlighting the need for more accessible and nourishing food option. This is why we chose adlai as our main ingredient, due to its rich, nutrient-dense profile and suitability to support the dietary needs of growing children. This became the foundation of our energy bar. And you may wonder how a simple adlai grain can be transformed into a nourishing yet delightful energy bar. To develop the adlai energy bar, we began by preparing and testing adlai as the main ingredient, then combined it with other nutritious components. Through a series of trials and adjustments, we refined the product until the desired taste, texture, and consistency were achieved. Each step brought us closer into creating a healthy and enjoyable snack. Additionally, the adlai energy bar was created to help address nutrient deficiencies in communities of Quezon City. Now, creating the perfect energy bar isn't as simple as it seems. For our first attempt, we primarily washed the rice to rinse off dust, insects, or bits of husk that was left from the hulling process. Once dry, we have decided to air fry the adlai rice raw for 15 minutes. The result became hard to chew and overall the wrong fracturability we were trying to achieve. For our second attempt, we again washed the adlai rice. Once dry, we decided to cook the adlai rice for 20 minutes because in achieving the right fracturability and texture mainly relies on moisture. As we air fry it for 20 minutes, the heat vaporizes the trapped water in the adlai grain as it slowly expands, fulfilling that light and crunchy texture. Our energy bar contains bananas, mangoes, oats, peanut butter, and raisins to create that perfect and energy-packed snack. Powered by adlai, our energy bar delivers sustained energy while also promoting a more active and healthier lifestyle. To evaluate the product's acceptability, we conducted taste tests among the children in Quezon City. The results showed a positive feedback regarding its taste, texture, and overall appeal, indicating acceptability and potential as a practice for a nourishing alternative.
We ourselves find eating healthy food troublesome, and during the development of the adlai-based energy bar, we learned that it is possible to create a nutritious snack that is still enjoyable to eat using adlai grains. Due to the nutritional value that adlai grains offer, we found that by incorporating it into an energy bar, healthy snacks do not really have to feel like healthy food. One of the obstacles we faced is the cooking of the adlai, as it wasn't something we were accustomed to. It provided us valuable learning experiences and demonstrated the potential of adlai-based products for future development and healthier food choices. And as the development of our product progressed, our problem-solving skills also progressed as we adapted through trial and error. And as mentioned earlier, the development of the adlai-based product that we researched on provided valuable learning experiences and helped us to learn how to adapt in many ways, especially since adlai wasn't something we were accustomed to. All in all, creating this product was more complex than it seemed, and it pushed us to think beyond and move away from our usual cooking methods and try different approaches to find the right ingredient for the outcome we wanted to achieve. And as our presentation comes to an end, the story of adlai goes on. Future researchers can still improve our product through the addition of other functional ingredients and other suggestions. adlai Energy Bar is not just a product, it is a vision for a healthier and sustainable future where everyone can embrace better nutrition and make adlai as a part of a healthier lifestyle. And like a candle, even a small light can make a difference.
Once again, live the life with adlai. Thank you so much.
Thank you so much. Our next presentation is from Sendai Seiryo Secondary School, Japan. The topic will be crab shells can save the planet, creating a circular society through cheating's absorption power. Please welcome the team.
We are from Sendai Seiryo Secondary School in Japan. Today we will present crab shells can save the planet, building a circular society utilizing the adsorption power of kaiten. We focused on kaiten, a natural component found in crab and shrimp shells that is usually discarded as garbage, and researched its potential as an innovative, non-polluting metal recovery filter. First, let's look at the background. In our modern lives, metals and nanometals are very important. However, there are three major challenges. First, buying resources from only a few countries is risky. Prices can go up quickly or the supply might stop. Second, traditional mining uses too much energy and makes a lot of CO2. Third, we need to reduce resources. To protect our future, we must stop digging up new resources and start recycling. Recycling what we already have.
So we focused on the ocean. Seawater has much more rare metals and resources than the land. But there is a major issue. They exist at extremely low concentrations. It is like trying to one drop of ink in a huge swimming pool. Traditional ways to find rare metals cost too much money and hurt the environment. Therefore, our goal is to find this easy, clean way to find these metals, even from low concentrations. Also, our research helps achieve SDG 9. I'm sorry. Okay. SDGs 9, industry, innovation, and infrastructure, and 12, responsible consumption and production, and 14, life below water.
So, what exactly will we use for the recovery? The answer is discarded crab and shrimp shells, namely natural. These shells, which are generated in large quantities by the seafood processing industry, are an inexpensive and sustainable resource. Chitin has a structure very similar to cellulose, the main component of plants, but with a crucial difference. It has an organic compound named acetamide in it, which contains nitrogen atom within its molecule structure that plays a vital role in capturing metal ions in the water. It makes it an effective and low-cost filter which can reduce industrial seafood waste at the same time. Let's look closely at the chemical mechanism of absorption. This is cellulose and this is chitin. As explained earlier, it can be seen that chitin contains nitrogen, which is absent in cellulose. When metal ions approach chitin, this nitrogen atom forms a bond surrounding metal ion. This is called a chelate bond because nitrogen forms a strong and stable bond with metal ions. Chitin can selectively and powerfully absorb metal ion dissolved in water.
Okay, so to verify our hypothesis, we conduct conducted a four-steps experiment. First, we prepared the individual and mixed solutions of copper, nickel, and cobalt. Second, we added chitin to the solutions and stirred them for 24 hours. And third, after letting the particles settle, we measured the clear liquid with the spectrophotometers to calculate how many ions were not absorbed. Finally, we checked the color change of the filtered chitin using glycerin to detect any remaining copper. Next, to measure the amount of each metal, we created a collaboration curve. Figure 3. This shows the absorbance spectrums of the mixed solution. And as you can see here, the peak wavelength for nickel for 390 nanometers, cobalt for 510 nanometers, and copper for 800 nanometers. In this figure 4 shows the relationship between the concentrations and the absorbance. Lower absorbance means fewer metal ions remain in the solution, and this means more absorbed by chitin. Then we use these collaboration curves to calculate the concentrations of each metal.
The right photo shows the chitin washed with a large amount of pure water and dried after absorption. As you can see, the left chitin, you can see that it remains a blue-green color compared to the original white chitin even after washing. We concluded that this was a chelate bond occurring between the nitrogen atoms in chitin and copper ions. Understanding this allows us to optimize the process and establish a highly stable and reliable recovery method. Now for the experimental results. In our first experiment, we limited our test to chitin and single metal solutions. Our top priority was to accurately understand the baseline absorption properties of chitin itself and see how its capacity changes with mass without any interference from other factors. As shown on the table, when the amount of chitin was increased, the level of metal in the solution decreased. This indicates that more metal ions were absorbed. And calculating the absorption amount per 1 gram, we first obtained data for copper, and in the same manner, for nickel and the values for nickel and cobalt were calculated as shown below. For the next step, we created a mixed solution to simulate real seawater. Here, we used cellulose as cotton as a cellulose sample, and to compare the structural advantages of chitin. Specifically, how the presence of acetamide groups creates a difference in absorption power. As shown on the table, when cotton was added, there was no change in absorbance. But when chitin was added, the value of absorbance of copper decreased. Converting this to the amount of absorption, chitin absorbed copper ions in this manner, whereas nickel and cobalt, calculated in the same way, were virtually not absorbed. From these results, we concluded that in an environment where multiple metals are mixed, chitin possesses the ability to selectively absorb copper ions. This is extremely important because real-world seawater contains a mixture of many elements. Chitin's selective ability means we can efficiently recover target metals without wasting its capacity on unwanted substances.
Through this research, we have demonstrated the possibility of transforming waste, such as crab and shrimp shells, into valuable resources. Okay, resources. I'm sorry. And what we aim for goes beyond the mere circular economy. In our home prefecture of Miyagi, we have beautiful Matsushima, one of the 3 most scenic spots in Japan. But our starting point is not only to receive the blessings of this rich sea, but also to use the power of the sea, kaijin, to solve the challenges of waste and technologies we have produced, thereby protecting and keeping the sea beautiful. And seawater knows no borders. From our local sea to the ocean of the world, it is only to the construction of a circular society where nature and humans truly support each other and that we can live in harmony. Below are the references. Thank you for your attention.
Hello everyone, so I'm the judge, Professor Chai, and I would like everyone, the previous group, do very good presentation, okay? But I would like to share one reminder for presentation skill on the stage performance. Okay, when you do the presentation, it's not necessary for you to stand from, because the high desk is going to block the view. Okay, so actually, I sincerely suggest you, when you do the presentation, actually you can stay here, okay? Will be more professional. And okay, even you have like a speech cheat sheet, you still can put here. Okay, it's better to stay here. That will be make your stage performance is better. And the second thing I would like to remind you, eye contact with the audience is also important. Okay, good luck. Thank you.
Thank you for Professor's comment. So next one, the next presentation is from GT Ellen Young College, Hong Kong. They are going to share with us a new idea towards sustainability. The topic is enzymatic delinking by localized bio-waste extraction, a sustainable approach to closed-loop paper recycling. Please welcome them.
Good morning, esteemed judges, guests, and fellow students. We are the team from GT Ellen Young College. The recycling rate of paper is alarmingly low at 42% in recent years, while it continues to be the third largest component of municipal solid waste dumped into landfills. Even though conventional chemical de-inking allows paper reuse, the process generates significant water pollution and greenhouse gas emission. Therefore, we evaluated a sustainable alternative approach by using biological enzymes combined with local organic waste as natural fiber reinforcement to reduce chemical reliance and environmental impact. During the process, we have 4 specific goals. First, to compare the enzymatic de-inking efficiency, paper quality, and environmental impact against the chemical method and the control. Second, to assess the feasibility of laboratory-grade and homemade enzymes. Third, to develop functional, writable, recyclable paper prototypes for schools to use in a waste-minimizing and closed-loop system. Fourth, to establish a low-cost, scalable framework to foster community-sustainable practices. During the process, our initiative supports 3 SDGs. First, SDG 12, by replacing polluting chemicals with biological enzymes treatment. SDG 13, by lowering methane emissions from landfills and reduce energy-intensive processes. SDG 15, by conserving forest land and preventing soil and water pollution. Today, we will cover our experimental framework, results, problem-solving journey, and future exploration.
Now onto the experimental framework. Traditional chemical de-inking commonly uses chemicals like sodium hydroxide and hydrogen peroxide. These chemicals are effective, but may produce harmful effluents that require careful handling. As an alternative, enzymatic de-inking uses biological catalysts to break down particles surrounding material surrounding particles. This method is not only dense on paper fibers, but it also It is also environmentally more sustainable, although it often requires longer processing times. Our experiment consisted of 4 groups. Group 1 served as control and underwent only mechanical processing. Group 2 underwent conventional chemical treatment using sodium hydroxide and hydrogen peroxide. Meanwhile, Group 3 used a commercial blend of enzymes, specifically cellulase and xylanase. Finally, Group 4 used homemade enzymes obtained from decomposing leaves and soil, presenting a low-cost and locally sourced alternative.
So, our experiment consisted of 3 major stages, as you can see there on the left-hand side. First is pulp preparation and standardization, where we added 20 grams of dry shredded paper to 384.8 millimeters of liquid, consisting of water and a treatment solution. It was then blended at 210 rotations per minute for 60 minutes in total, set at specific temperatures. At the same time, the pulp consistency was standardized to around 4.94% to ensure uniform fiber development and sheet homogeneity among all experimental groups. And the next stage is mechanical de-inking and purification, where the pulp was then blended for 90 seconds, and the high shear force generated by the blender helped to detach any loose ink particles from the paper fibers. And then the blended paper pulp was sieved and rinsed thoroughly with distilled water, which removes some impurities such as chemicals, minerals, and enzymes. This ensured that the paper quality reflected the effectiveness of the treatment solution rather than the effect of leftover residues. And lastly, in sheet formation, the purified paper pulp was then suspended in water, and a mold and decal were used to collect the paper fibers evenly. And then the paper sheet was then drained, and it was transferred onto the paper cloth, where excess moisture were removed. And at last, as you can see here, it was allowed into the air to dry. And so this process allowed us to evaluate whether our sheet of paper pulp can be converted into practical and writable recycled paper.
This table here shows the results. First, all groups successfully reduced the amount of ink particles compared to the control. The laboratory enzyme group, Group 3, achieved the lowest average number of ink specks, around 3.7, while the chemical group and homemade enzyme group performed similarly, both achieving about 31.7 specks. However, another important observation is paper quality. Group 3 achieved the lowest average at only 69 grams per square meter, compared to 83 to 87 GSM in the other groups. Several conclusions can be drawn with these results. First, all groups were effective in removing ink compared to simple mechanical processing alone. Second, strong enzymatic activity have removed not only ink particles, but also paper fibers, reducing the final paper yield. Therefore, while commercial enzymes may have achieved superior ink removal, there may be a trade-off between the inking effectiveness and fiber preservation.
Most importantly, homemade enzymes demonstrated results comparable to traditional chemical de-inking methods. This demonstrates that locally sourced biological materials may be potential as sustainable de-inking agents, but despite such, challenges still remain.
First, we encountered time constraints. Making a single sheet of paper takes 1 to 2 days, which limited how many tests we could do. To save time, we standardized our experiments by keeping the paper mass at exactly 20 grams and also the de-inking process duration at 6 minutes. This allowed us to run multiple tests side by side. Second, we have environmental controls. Changes in room temperature and humidity made it hard to get a large yield of enzymes continuously. So we made a large batch of enzymes right at the start. And using this for our entire experiments keep the conditions completely fair and consistent. Third, we have technology limitations, as we didn't have advanced machines or chemicals to test the strength of homemade enzymes. So we carry out simple tests like the Benedict test to prove that our enzyme is active and working before we do our experiments. And the last is about data errors. We try to use an AI app to count the amount of ink spot on paper. However, it kept missing it. So we changed to use a manual effort by counting the amount of ink spot in specific square by eye. This allows us to get more accurate results. We realized that our green method works. However, doing everything by hand is highly inefficient. The process is time and water consuming. As the paper is produced manually, the smoothness and smoothness the paper is uneven, and also incomplete blending even left large text fragments on the paper which compromise the quality. These experiments prove that low-cost recycling system is possible without expensive reagents, and we learned that experiments do not rely on advanced technologies. We can still conduct value scientific research in simple materials, and the most important factor in scientific research is a positive learning attitude. Looking ahead, we would like to use automatic blenders and presses to make the paper more smooth and uniform. We would like to expand our testing, including transmission, whiteness, tensile strength, and also how pure our homemade enzymes are. And our ultimate goal is to make this eco-friendly recycling system easy and cheap enough for any school to use.
So you guys may wonder how the paper can be complete in the closed loop system. So we have bring some products to here. Okay, so we can see that our paper, after de-inking, can be written by different kinds of pen, act as drawing paper, craft paper, or even paper folding. So actually, the inking process allows the paper become more appealing and suitable for writing and drawing. So in conclusion, our project successfully demonstrated that enzymatic inking combined with local organic waste is a viable and environmentally friendly alternative to traditional chemical methods by achieving comparable de-inking performance with homemade enzymes. We have shown that schools can implement similar closed-loop system in their community to reduce chemical pollution, minimize landfill waste, and promote competition. So our work has strongly supported SDG 12, 13, and 15, and we hope it can inspire other students and schools to adopt similar sustainable practices in their community. And these are the references during our research progress. Thank you very much for your attention. This is our presentation. Thank you.
Thank you very much. So our speakers are from Kyoto Prefecture, Toba High School, Japan. The topic is the black-based fertilizer project, exploring its potential as a commercial fertilizer using quantitative analysis. Please welcome the team.
Good morning, everyone. We are from Kyoto Prefecture Toba High School. Our team members are Yoshida Sei, PJ, and me, Matsukura Yu. Thank you for inviting us today. The title of our presentation is The Black Bass Fertilizer Project. We focused on SDG goal number 15. Life on it to protect ecosystem and biodiversity. One great danger to biodiversity is invasive species. Our home Kyoto is affected by one of these species, the black bass. Black bass is a carnivorous freshwater fish native to North America. This slide shows the global spread of black bass. Because it is popular in sport fishing, it has been released in many countries. It has a huge negative impact on native species. As you can see, black bass has spread to Japan. For our research project, we focus on Lake Biwa, next door to Kyoto. It is Japan's largest freshwater lake. Much of Kyoto's drinking water comes from Lake Biwa, so it is very important to us. Black bass cause ecological damage to Lake Biwa. Unique native species like river trout and Nigorobuna carp have greatly decreased. To protect these species and others, local governments have been trying to capture and remove black bass. However, it is costly and difficult. Moreover, most of the captured bass are simply discarded and wasted. To improve up the idea turning black bass into commercial plant fertilizer. This is what we envision. Captured black bass are removed, collected, and processed into fertilizer. It is sold, and the profit found by host and so on. In this way, we turn our invasive species into a viable resource and protect the environment. So, such question: can black bass fertilizer be developed as a viable commercial product? The roadmap to commercialization has 6 phases. We have already completed phase 0 and 1. In phase 2, we convert the effect of fertilizer to commercial organic fertilizer. Next, we will explain our experimental method.
First, we went fishing for black bass at Lake Beaver. You can see us fishing here. We caught the fish and dried it. Then, we crushed it to make fertilizer. This is a black bass fertilizer we made. It's quite a lot, don't you think? To test our fertilizer, we did an experiment with 4 groups, A to D. Group A had no fertilizer. Group B used commercial organic fertilizer, 5 grams per liter. Group C used black bass fertilizer, also 5 grams per liter. Group D used 10 grams per liter. We did Komatsuna in all groups. We will explain why we chose this plant later. After 30 days, we harvested the plants. We weighed the plants and rated the appearance. We used analysis of berries and over to see if there were significant differences between the groups. We also used weight tests to compare Group C with Group A, B, and D. Our next speaker will discuss the result. In this experiment, we faced 3 challenges, which you can see here. First, we needed a round number of black bass. Why? Because the amount becomes smaller when it is dry. However, in winter when they are less active, black bass can be difficult to catch. To overcome this challenge, we went fishing at here or the port. The water is warm even in winter because of outflow from water treatment plants. It is famous as a black bass fishing point in winter. In addition, we asked the local anglers to let us have their catch. As a result, we were able to collect more than 2.7 kilograms of black bass. Look at how many. Oh, I can't count.
The second and third challenges were time and season. After the first 2 phases of our project, we had only 3 months until the end of the term to complete this phase. Moreover, because it was winter, it was cold. This can have a negative effect on organic fertilizer. In order to work, organic fertilizer must be broken down by microorganisms in the soil. In cold weather, they are less active. This is where komatsuna comes in. Komatsuna is a Japanese vegetable. It is used in many traditional dishes. It grows quickly, even in winter. Also, it is very delicious. In addition, we built our first house to help keep the microorganisms warm and active. In this way, we were able to overcome all 3 challenges.
Next, I will introduce what we found out in. This table shows the results of our experiments. On the left, you can see groups A to D. On top, you can see the mean weight, SD, PV, survival rate, and visual score. As you can see, Group B, which is commercial fertilizer, showed the most growth. Group C, with fertilizer, was second. Group D with 10 grams faster. Another test confirmed that these differences were statistically significant. In other words, not random. In this graph, you can clearly see the results. Where these T tests confirm that there were significant or very significant differences between Group C and the other groups. From these results, we can say at this point, it is difficult for blockbuster fertilizer to compete with commercial ones. However, we believe it still has potential. Let me explain. This graph shows the coefficient of variations CV. CV indicates the stability of the results. As you can see, the CV of Group D is over 100%. Group C is also quite high at nearly 60%. We believe that this instability shows that the effect of fertilizer is very sensitive to the amount used. Let's look at what this means. In our reflection, we identified 4 areas for improvements. Among them, we believe that optimizing the amount is critical. The high CV of Group C and D suggests that we should reduce the amount used. In fact, the optimal amount may be less than 5 grams. This is less than commercial fertilizer. This could be a selling point as a commercial product. That is why the most important message that we want to share is Blackfast has potential as a commercial fertilizer. Finally, let me show our vision for the next steps. In the next phase, we will do experiments to find out optimal amount of breakfast fertilizer to use. Then we will check safety and finally make a commercial product. In fact, we have already started phase 3. If we succeed, we can create a positive cycle which turns an invasive species into a viable resource and helps achieve SDG 15 by protecting local ecosystems. That is our vision. This is references. Thank you.
Thank you. Next, we're going to students from National Stanford School. They're going to talk about enhancing solar panel efficiency. Please welcome the team.
Hello. Good morning, everyone. My name is Ray from China First High, and this is my brother Jason. So today we're going to introduce our project, Enhancing Solar Panel Performance, a step toward SDG 7. The project mainly focuses on how we can make solar panels work more efficiently and what it means for our planet. And here is the agenda of our presentation. Please take a look at it.
Okay, so the slide shows the overall summary of our research. We first decided to focus on solar panel efficiency, and then we did our research to learn about the mechanism of solar panel. And then we carried out the experiment that we designed. After collecting the data, we analyzed the results and causes behind it. Based on that, we developed several suggestions.
So as you can see, the project focuses on SDG 7 for clean and affordable energy. This aligns with our goal to improve the efficiency of the solar panel. And after deciding our research interests, we started to search for some information, and we found out that many of the solar panels could only convert a small portion of sunlight into electricity. This is how it happens, and rather simple factors such as light colors or illumination area of the solar panel could do a noticeable difference. This curiosity became the starting point of our research. And next, let's talk about the mechanism of solar power. So as solar power relies on silicon, but why? In band theory, metals have overlapping and no band gap, so light energy turns into heat and loss. That's why metals cannot generate electricity. In contrast, Silicon, which is a kind of metalloid, has a perfect band gap that traps photon energy, helping electrons jump into the conduction band. This enables the photovoltaic effect. So microscopically, pure silicon uses covalent bonds, but has two goals. First, conductivity is poor because electrons are locked, leaving no carriers. Second, electrons and holes can easily recombine, and without the separating force, they instantly jump back together, wasting light energy completely. To solve this problem, we use a technique called doping. We add phosphorus to create an N-type semiconductor with extra electrons, or add boron to create a P-type semiconductor with holes. Doping improves conductivity and triggers a physical effect at the interface.
When p-type and n-type touch, they form a p junction, and carriers diffuse and recombine, leaving the negative charges on the p side and the positive charges on the other side. This will create an internal electric field and works like a one-way magnetic core, serving as a pump to separate electrons and holes. And finally, here is the complete structure. The internal electric field will push electrons to the N side, the holes to the P side, and this works like a negative core, and the electron will force through the external circuits and to as current to drive the load, and this enables the solar power to operate continuously. And next we have our first experiment to introduce. Okay, so parts of our experiment, we tested the effect of different light wavelengths, and we place different colors of cellophane over the whole of the box. Direct the flashlight to illuminate the solar panel. Using data from the multimeter, we observe the generated electrical currents and voltage. By doing this, we simulated how clouds and fog reflect light into different parts of the spectrum before reaching the solar panel. And here is a table for show our data. As you can see, the data, the highs from lowest are white, yellow, red, green, and blue. And white come with a 6.1 megawatts, and the blue one come with 0.4 megawatts. And this is the bar charts that we create to show our data more clearly. So the next part is the discussion of our results. During our research, we found out that the solar panel we use aligned with the spectral response of crystalline silicon. And the graph in here indicates that the solar panel is more sensitive to lower wavelengths, such as yellow and red. Light produces the highest outputs because it contains the full spectrum of lights. However, light should theoretically have the highest outputs, but yellow and red light surpasses, and the light intensity theory can explain it. As you can see from the equation, the light intensity for each light is kept constant, and the number of photons vary with the frequency of light. And blue lights with the highest frequency comes with the minimum number of photons, and the number of photons directly affect the outputs. So let's explain why blue light yields the outputs. And next, in conclusion, different energy level contain different light wavelength, and the solar panel efficiency depends on the solar panel use. Next, we have Ray to introduce our second experiment.
So in our experiment 2, we change our focus from light colors to illumination area of the solar panel. By covering different portions of the solar panel, we see situations like shadows from buildings and dust accumulation. And then we observed how those changes affected the electrical output. And in this experiment, we only modify one step from our previous one by replacing the color cellophane, which is used to cover the panel surface. Okay, so this slide shows the final data regarding to our experiment 2. And you can see that when the illuminator is 5%, it produces the highest power, which is 34.23 megawatts. And when the illuminator is only 75%, it produces the lowest power, which is only 2.5 megawatts. And to present our results more clearly, we convert our data into a chart. So as you can see, the pattern is as the illumination area decreased, the power output dropped significantly. This shows that even partial shading can strongly reduce the efficiency of the solar panel. And that is the conclusion of our experiment. So next, let's talk about the suggested improvement. And to improve the status quo that we observed from our experiment, we generalized two main points according to our experiment data. So for the first one, in our experiment, we use color cellophane to simulate cloudy and foggy conditions. The color cellophane how cloud or fog change in light that hits the solar panel. And then we observe that under those conditions, short wavelength light is reduced, while mid to long wavelength lights can still pass through. Therefore, based on our experiment data, we suggest choosing solar panel according to regional climate. Panels with better to long response are more suitable for cloudy and foggy areas. And for our next testing improvement, in our experiment, we use cardboard to simulate and clean the panel. The cardboard represents dust and dirt covering the panel surface. And then we observe that when the panel is unclean, less light can reach it, and the efficiency drops significantly. Therefore, based on our data, we suggest regular cleaning and doing shadow and light analysis before installing. We believe that good maintenance and proper placement can significantly improve the efficiency of the solar panel. And next, Jason will introduce our review on the research.
So several areas of experiments need improvements. So first of all, the paper box used did not fully eliminate external light interference. So in future trials, we should conduct the experiments in a fully dark room. And furthermore, owing to the size time constraint, we only conducting a single time trial, which will decrease the data accuracy and prevent us from calculating a reliable average. In conclusion, even though we have made progress in our energy technology, we still share only on Earth. And we should not only generate more power, also using more wisely. And these are the references we use for research. Thank you for your listening.
Thank you. Next, the team from National Pingdong Senior High School is going to speak about self-powered electrophoretic separation device based on a zinc copper battery. Please welcome the team.
Good morning, everyone. We are from Pingdong Senior High School. My name is Yang Qiming. Beside me are Han Youcheng and Chen Zhaojun. Today, we would like to introduce our research project, self-powered electrophoresis via source bridge potential difference in the zinc copper galvanic cell. Our research was inspired by a news report about pollution. In this report, that synthetic dyes are pollutants commonly found in industrial wastewater and are one of the major causes of environmental pollution. This led us to ask a question: is there any effective way to separate and detect these pollutants? To achieve this goal, we combined a traditional zinc copper battery with paper-based electricity to create a prototype device. In this device, the plate and copper plates serve as negative and positive electrodes, respectively, and are placed on filter paper soaked in sulfate and copper sulfate solution. The two electrodes are connected by filter paper salt bridge, soaked in potassium chloride solution. Our device utilizes the principle of electric osmotic flow. Inside the device, the negatively charged surface on the filter paper attracts cations to the solution and forms an electrical double layer. As electrons move toward the copper plates, these already arranged cations are attracted in the same direction, driving the movement of the solution. This natural driving force is generated by ion migration and allows pigments to be decorated without any external power supply. Next, I will invite my partner to introduce our challenges in research.
Okay, in this part, I would like to introduce the challenges we have with our research. First, we use a metal plates to complete the circuit, but we find they cause stable current. So we switch to alligator clip and wrap the metal plates with their filter paper. As a result, current become more stable and increase. And the second challenge is that dye diffuse too quickly after spotting onto the salt bridge. So we switch to use 10% dye aqueous solution and add glycerol at a ratio of 1 to 0.5 before spotting. And the third challenge is that during our green bead dye separation experiments, we find sometimes dye remain at the spotting point and the move. It's difficult to obtain a satisfactory result. We replace the original filter paper with gas fiber filter paper and change potassium chloride solution to potassium chloride solution containing 10% alcohol. And after stopping the control variables, we add two detection methods. The first method is light and color sensor. During our experiments, the white light illuminate onto the salt bridge, and the reflected light from the salt bridge is received by the RGB sensor on the color sensor. Through this method, we can note the movement of dye on the salt bridge in real time. And the second detection method is an AI called Oslo Progress. We use lab photography, and the video was imported to an program developed AI assistant. Then, and by selecting the detection points, we can the program can generate the chromatogram-like graph. And this is our final experiment setup. The cell phone is mounted underneath the device, and the light and the color sensor is positioned 1 centimeter away from the starting point. And now I will use the green bead dye separation experiment and example. Let's look the light and the color graph first. And you can see at point, all three value decrease, and with the G value showing decrease. This is because the green bead dye pass through the detection point and cause the decrease of all three values. And at B point, the B value increase and exceed the R. This shows that blue number 1 pigment, 1 component of green bead dye pass through the detection point, but the yellow number 4 has not yet. And at C point, we can see our value increase significantly. This shows yellow number 4 pigment has passed through the detection point. And next, the epoxy chart from cell development program. We can see that real world 210 seconds, the B value increase corresponding to the point of light and the color sensor chart. And we can see at real world 11 times 1,200 seconds. We can see our value increase significantly. So it's corresponding to the C point of light and the color sensor chart. These RGB trends are totally consistent with the result of light and color sensor. Next, I will invite my partner Chen Daojun to introduce the future and the conclusion of our research.
I will talk about the advantages of our device. First, it is cheap and the total cost is less than $30, making it an economical alternative to laboratory equipment. Second, it's portable. The device is lightweight and compact, making it easy to carry. Third, it is energy efficient and eco-friendly. The device requires no extra power supply and operates using its own generated electricity. But how can we connect our device to SDGs? People can use our device to monitor water equality and identify dangerous pollution at every stage. More importantly, components of our device is recyclable and reusable. This means that all this process doesn't impose an additional burden on the environment. Looking ahead to further enhance our waterways analysis capabilities. Currently, we have successfully demonstrated the separations of specific dyes. In the future, we hope to expand our separations target to include a wider varieties of synthetic dyes, such as multigreen and Congo red, as well as some heavy colored metal ions. In summary, we have developed an integrated paper-based electrolysis and color sensing system. This device is portable, cost-effective, and sustainable. We hope that this innovative technology serves as an early warning water equality monitoring and help protect our water resources all around the world. This is our report. Thank you for your patience.
Thank you. Next, the team from Fun Yu High School, Johor Bahru, Malaysia, is about to speak about AI in the cloud, drought on the ground, the hidden hydrological crisis of the global computer race. Please welcome the team.
Hello and good morning, everyone. We're from Bunyu High School, Johor Bahru in Malaysia. And now I want you all to imagine yourselves living in a community where access to fresh water is extremely limited and toxic chemicals and heavy metals are deposited into local water sources, polluted soil and aquatic ecosystem. Unfortunately, that's the reality for millions of people worldwide living in close proximity to AI data centers. And to address this, our team tackles the hidden hydrological crisis of the global computing race. Starting with the outline of our presentation, we'll go over our motivation for starting this project, our methodology, our actions, and lastly, our reflection. First, let me tell you about a story that became the main source of our inspiration. On February 7th of 2026, more than 50 residents, representing around 1,000 people, protested against a mega data center being built in close proximity to residential areas. The project caused severe dust pollution and posed a high risk of water supply depletion. The government responded by freezing data center approvals for high water consumption, which was about 50 million liters of water daily, equivalent to meeting the daily water needs of the entire population of Malaysia for approximately 10 minutes. And now that you understand the impact, let's go over how data centers actually consume water. So it starts with a single user response. This action triggers a series of calculations at the data center. This causes computer hardware to become heated to the point where permanent damage may arise without adequate cooling. And so, municipal fresh water is blasted into cooling towers to dissipate heat. The result? Fresh water is permanently evaporated into the atmosphere, leaving an empty water basin. This simple process creates an unprecedented environment impact, where just one hyperscale AI data center can consume up to 5 million gallons of water daily, equivalent to meeting the daily water needs of 50,000 people. Every time we use AI, we're part of a massive global boom. It drives trillion-dollar profits, tech breakthroughs, and boosts productivity. But that's the macro benefit. Rarely anybody talks about the hidden microcost. Right now, local communities are paying gas. Millions of gallons of water are being drained daily, and toxic chemicals are leaking into water basins. The question is, how can we balance technological advancement and the well-being of local communities? Now, I'll let Yi continue the presentation with the methodology and findings for our project.
Thanks, Chiheng. We have seen a micro-level crisis in Johor, but we wanted to know that if we just realize this is happening right now in our backyard. To investigate this, we designed a campus-wide survey to map the cognitive gap among digital natives. Our hypothesis was clear. Despite using generative AI constantly, students possess critical cognitive blind spot regarding its lower water costs. We collected 250 valid responses from senior grade students in our school, and we built our survey with the goal of assessing their awareness of environmental issues, personal AI habits, and also their behavioral reflection. Now, let's look at our findings. Only 15% of our respondents even knew that data centers consume fresh water. This was one simple thing. Most of us are just using AI tools without knowing the cost behind them. But here's the turning point. About 83% of our students say that they would change their behavior if the AI tools clearly display the water cost of each prompt. So this indicates that our students are willing to change. We just need to know the facts. So what are the facts for our campus? With about 500 students sending 31 queries per day, and each query costs approximately 2.85 millimeters of water. Now multiply that by 250 school days a year, we get over 110,000 liters of fresh water evacuated every single year. Imagine scaling that to every school, household, and office all over the world. To visualize this massive impact, we built a website which Sun Yi will now introduce for us.
Thanks. We want to emphasize that AI is an abstract concept. It is built on data centers that consume massive amounts of water. Today, I would like to introduce an education website, Aquametric. This is interface, and you may scan this QR code to follow along on your devices. It functions as a simple calculator to help each organization to quantify the footprint behind their AI usage. Our intention is to unmask the hidden hydrological impact of AI, thereby promoting awareness and responsible usage of AI technologies. First, choose the calculation mode, and we choose employee queries. Just input the number of employees using AI, average daily queries per employee, and primary AI tool use, such as GPT-4 or Claude. There is a crucial section here, data center region. Why is this matter? Because water efficiency in cooling systems varies significantly based on climate. In hot regions, the water loss by cooling is much more higher than in cooler regions. This makes our assessment accurate. Once you have entered the data, there will show an instant result on the right-hand control panel. But a raw number lacks impact, so Aquametric provides a solution. It converts it to standard 500 millimeters of water bottle it represents, and also converts it into an equal amount of refugees survived. This is a small amount, but you are not prompting alone. What you just see is the impact of an individual or a small team level. But you ask, if it's not just our company, but the whole industry using AI at this scale. Look at the scale-up scenario at the bottom of the page. Using this slider, simulate the total water consumption of institutions in AI. The scale set up to 500 times, the total water consumption will jump up from 0.1 million to 55 million liters of water. For those who are interested in the technical background, our website also provides the methodology and the deep dive sections
further details. Lastly, I will let Elisa to conclude our presentation with the reflection and the lesson learned during this project.
Thank you, Sunny. Now, let us begin with a major psychological hurdle we encountered, the awareness action gap. Simply knowing an environmental crisis doesn't automatically translate into a change in behavior. Our core question became, how do we bridge this gap and drive meaningful behavioral change? To solve this, we proposed an innovative hypothesis, the implementation of real-time water cost labeling. Real-time water tracking on AI interfaces would force users to see their environmental impact. This brings us to real-time water cost labeling would cause them to see on their impact. Our ultimate goal goes beyond just informing the public. It is about designing tools that actively disrupt unsustainable digital habits. To assist future explorations, our team proposed a strategic roadmap. In-person studies around regional data centers must be accomplished. However, independent action isn't sufficient. We must advocate for formal policy integration. We need to push for water usage disclosure policies and legal transparency mandate that force tech corporations to pull back the curtains on their resource consumption. To conclude, our project centers on a delicate act of equilibrium, balancing innovation. We're not anti-tech, but we must acknowledge the tension between digital innovation and environmental protection. Up until now, the digital economy has externalized its environmental costs, pushing onto local communities. This brings us to the systemic issue of accountability. It is imperative that tech monopolies are accountable for the physical footprints of their virtual products. Lastly, we want to leave you with one truth that summarizes our presentation. The survival of the cloud ultimately depends on the health of our soil. Thank you.
Thank you. Next, from Hito Vita Yanuson School, Thailand, is about to share with us their research outcome. Their topic is smart water monitoring, automatic detection of microplastic in water using polarization imaging and machine learning. Please welcome the team.
Think about the world we live in today, with many challenges such as environmental issues, living conditions, and also sustainabilities. So, if we want to address those problems, we need to achieve the sustainability or SDG goals. So, our focus is on SDG 6, or water and sanitation, focuses on providing safe water, also cleaner sanitation for everyone, because this is important for our health and also environmental protection. Water is essential to our daily life. Water, a natural water source, sustains us. However, have you ever wondered what might be hidden under this water? Plastic waste can enter water and gradually break down into microplastics that we cannot see with the naked eye. Good morning, respected judge and distinguished guests. We're from Mahidol Vichyanus School, Thailand, and today we are pleased to present our project on water monitoring automated detections of microplastics using polarization imaging and machine learning. Microplastics are a problem that we face today. Microplastics are plastics that is smaller than 5 millimeters and can accumulate in aquatic organism and enter food chain, which can pose risk to our health. So we want to find the method that can detect microplastics in water, and the method we use
the principle of polarization of light. This principle is the principle that the light normally vibrates in many directions to only in one direction. Plastics have a special properties called birefringence. Plastics can change the planes of polarization axis. So if it is under polarization system, we see the plastics.
Let's see our methodology. In level, we study two factors that affect polarized light. Okay. The first factor is the orientation of plastic. We at night the background was darkness, given the highest contrast and making the microplastic easier to see. And the second factor is the angle between the polarizer and the analyzer. Next, for the experiment, we prepare the plastic to training the learning model, and we use the simple setup by a camera above film on an iPad, and we use like act as the light source. We collect image at 0 degrees, 45, 90, and 135 degrees. Then we train a ResNet classification model to detect the microplastic, and the model is 99% recall for PP, recall for PET, 97% recall for PP.
Now, after we got the model already, we want to build a prototype which is easier for users to use. So we need to prepare the microplastics first by we make a plastic smaller to make a microplastic, and then mix it with the water to make a contamination sample. And this is the sample container design. And then we need to take the picture of it under the magnifications of the microscope to get the microscopic image. We use the microscopic image to train the YOLO V11 data, which is the deep learning to detect microplastics. This is the sample of our that we use our model and then detect the microplastic. This is the image and this is the prediction results. Next, after we got the model already, we want to build the prototypes. Our prototypes work vertically by first, the light source is travel to the polarizers, change it to a polarization light, and then after that through a microplastic have a special properties which can change the polarization axis, and then through analysis that will to 4 angles degrees, and we're gonna take the picture from our smartphone. Then after that, the picture are analyzed using our developed model and then display via applications. This is the designs of our prototype. Also, we have designed a sample container as well to use with the prototype. This is the real prototype that we have built. So first, we need to insert the sample container into the device first, and after that, we're going to open the device, and then it's going to control the servo motor to change and rotate the analyzer to 4 angles. At 4 angles, you can see that it had different kind of intensity out. And then after we take the photo, we're going to upload it into the application for data processing and also displaying results.
And we also build a mobile application to make our system easy to use. This is our application front end. First, the user have to enter some simple information, including the location, the date, and water type. And after that, they have to upload image. After they upload the image, that comes from the last by using our device and press next button. Our application will send the image to our back-end AI model, which return a detection result, and also they will tell you about number of PET and PP particle found. And also, we build a history page. We hope this can be this data will become a useful resource for monitoring and studying microplastic
pollution in the future. Now let's jump to the result. This graph shown here is describe how well our model learned during training. See graph on the left, on your left, is the loss graph. See on top, the loss keep decreasing, so which means the prediction error becomes smaller and smaller during training. And you may see them look a little bit unstable because this one for validation data, which means the data that model never seen it before. So, but if you look closely into the scale, you is a little bit changed. So overall, it means our model learn well and they have no significant overfitting. And this graph is the for making more detail about our model. First one is F1 score and confidence. F1 score is a harmonic mean of precision and recall. So in simple terms, F1 score is high. Mean the prediction performance is good. So from this graph, we can choose the table. We can choose 0.2 to 0.9. This one is confusion metric, which compare the result to with actual level. So our model achieved PET recall of 94% and recall of 85%. Overall accuracy is 78%. And this is our result. And this is how it works together with application.
So to conclusion, I'm going to wrap up. So first, we can see that PET and PP show a distinct optical measurement that is different. So it's confirmed that the hypothesis of our hypothesis is correct. After that, YOLO V11 successfully detected microplastics with overall 78% accuracy, which is highly effective. And third, we have built a local and also a prototype can use in a local communities applications. So our project shows that we can make and also cost accessible detections of microplastic in local communities. And we know that approach is going to be better in the future, supporting a sustainable development. Our group, please, thank you.
Thank you. The next presentation will be brought to you by students from Suravi School, Suranari University of Technology from Thailand. The first topic is development of learning-based system for brain leaf disease classification and severity estimation. Please welcome with a big round of applause.
Good morning, respected chat and everyone in this hall. We would like to present our project, development of a deep learning-based system for durian leaf disease classification and for the severity estimation.
Durian is one of the most economically important crops in Thailand, contributing significantly to agricultural production and export too. However, durian cultivation is frequently affected by leaf disease, which can impact photosynthesis, plant growth, and food quality. In practice, leaf disease identification often depend on visual inspection and experience, which can be challenging when dealing with large cultivation area. We design one in deep learning and image analysis. These projects explore the application of convolutional neural network for analyzing images of leaves, classify disease type and estimate disease severity. The proposed system is intended to provide an analytical perspective that may support early-stage disease assessment and support informed decision-making for appropriate disease prevention and management. Let me go on to the next one. Convolutional neural network architecture. We already have explored different CNN architecture for plant disease classification, ranging from deep models such as ResNet to architectures such as MobileNet and efficient. And the another important technique is data manipulation. Data manipulation is commonly used in plant disease classification to address limit and imbalance dataset by increasing data diversity through information such as rotation, flipping, and scaling, which help improve model generalization and reduce overfitting. And the next one is severity estimation. Severity estimation refers to assess the degree of infection of plant leaves by quantifying the area or density of for early stage assessment. And this is our objective. First, we aim to develop a learning system for dural leaf disease classification to estimate disease severity from leaf image using segmentation and to evaluate and compare the performance of different CNN architecture and to implement the model in our application and for real-time research.
Our project is divided into two parts, the disease classification and severity estimation. Then we collect the durian image from Kakko.com, which contains 4 durian leaf disease and leaf class. And for the disease classification part, we first apply the data manipulation to increase diversity of the set. And in the process, we choose the CNN architecture, including MobileNet to ResNet 50, EfficientNet B0, and train them to get a model that can predict the disease. We training this model in Google.com using the image size of 224 times 224 pixels and the training input rate of 20. After fitting the model, we export the model into TensorFlow format for the mobile use.
For the server estimation part, we start by image preparing by using robot to pass our image, splitting them into leaf area and disease area. Then make our AI smarter. We have a data analytic technique which are flipping, setting, and adjustment to increase diversity of datasets. For the image processing, first export the JSON file from Roboflow to Google Colab and create the data and split into layers, which means we can separate mass to background, disease, and leaf area to be ground truth for our AI. And for training process, we choose unit architectures and training for 50 rounds at resolution of 204 by 224. And this is the most important part, the reconstruction and measurement. When disease tutorial leaf, part of it go missing. So we use convex house to reconstruct back its original shapes. This means it allows us to find the missing area. We then measure the area of disease, reconstruct the leaf, actually, and the missing areas by using NP. So finally, we will obtain stability by using this formula right here. Later, we export our models as TensorFlow lines to Google Lab to develop an application by designing the layout and using AI. Our AI can run and print the results on smartphone.
For our result, in the disease classification part, we generate the confusion matrix. And as you can see, these 3 confusion matrices look quite similar. So we evaluate them using the accuracy, recall, and A1 score. After the calculation, we see that mobile V2 achieve based on with the highest performance among these three architectures. And for the severity estimation pass, the graph of coefficient measure accuracy increasing and the model is increasing, which means our model is reliable. Application test, our model can tell the disease, which means our system is ready for use. Let's talk about sustainable development goal. Our project is relating to SDG number 2, number 8, and number 12. Our project is relating to SDG number 2, zero hunger, because of the early disease management, reduce crop loss, and improve food quality and productivity.
And our project support SDGs because scientists directly affect agricultural productivity and farming income. But in the detection and severity assessment, the system may help improve efficiency and reduce labor loss, contributing to sustainable economic growth.
And our support is well responsible consumption and production. By knowing the exact damage, farmer can use fewer chemical and saving money.
For the conclusion, the deep learning system safely classify the dually leaf disease, and can estimate the severity for the early disease management, and we found to show the balance between accuracy and efficiency for the durian leaf disease classification.
For the future, and we aim to refine our application user interface, make sure that the farmer can use application easily, and we aim to also have more features to our application. Thank you.
Thank you. The last presentation of the session is from VNU CM High School for the Gifted. Now, the topic of the presentation is Green Day, an AI-powered footprint tracker for sustainable living in Vietnam. Let's welcome them with a big round of applause.
Morning, everyone. My name is Lưu Chung, and today I'm joined by my teammates Phung Hưng and Yu Lao. We are from VNU HCM High School, Ho Chi Minh City, Vietnam. And today I want to ask you a question. How many of you know how many carbon footprints you use every day? If you don't, then today, down in the stage, I present you one and only solutions. I present you an AI-powered carbon footprint tracker for sustainable living. And remember its name, Green Day. Developing nations are growing fast, and so are the emissions. By 2023, Vietnam's per capita output reached 3.69 tons, five-fold increase in just 2 decades. But the numbers that concern the most are about a single country alone. They reflect a global health crisis. Around 60,000 Vietnamese die every year due to pollution-linked diseases. Has cost 6 to 7% of our GDP, and yet 93% of Vietnamese say that they support environmental actions. Only 3% of them actually practice it. That gap between caring and doing is the problem we have to solve. That is a survey with 112 respondents in Ho Chi Minh cities, and 96.4% of them can relate to that. 83.8% of them have never used an environmental tracking tool before. Values, the restrictions, people don't have the tool.
And this led us to two restrictions. First, to urban citizens adequate tools to measure and reduce their personal carbon footprint. Second, can an AI power with automated tracking and gamification effectively motivate sustained broad environmental behaviors? Our hypothesis is that if we give people automated, personalized, and gamified app, they will show greater environmental awareness and sustainable daily behavior compared to using manual tools or no tools at all. is designed to contribute 6 sustainables simultaneously. Most literally, goal 13, which is action, by translating the national NDC targets like Vietnam's goals of 15.8% reduction into something every to act on every day. Goal number 12 makes the carbon cost of purchase visible. Goal number 11, centers with city-specific CO2 data. Goal number 9 applies AI and computer vision into the sustainability challenge. Goal number 3 promotes physical activities through cycling nudges. And goal 17 connects eco-brands, World Health Fund, the United Nations programs, urban planners, and schools into a shared ecosystem.
Moving on to methodology. Case number 1 was the need assessment survey, where we received 112 responses from Ho Chi Minh City. 6.8% of which were adults and 17% were high school students. Phase number 2 was a comprehensive analysis where we evaluated existing goals, which are climate, climate here, EcoSIA, different criteria, which are automation, visualization, gamification, marketplace, and AI capabilities. And KDA was designed to address 5 gaps that competitors currently cover. And phase number 3 was a literature review where we drew on the global fog behavior model, 324 pages on gamification, the SDGs from Direct and the local mobile data usage. Moving on to our product development, which follows 5 phases: emphasize, build, validate, and scale. Decisions came directly from our data, where the opt-in GPS model came from the 75%. Privacy concern, the local efficient came from the Ministry of Natural Resources and Environment, EVN, not from market average. And our AI receipt reading ability was tested on 20 real invoices before the full development began. This ensures that every design choice has a data source behind to back it up.
Let's look at what our survey confirmed. On the problem side, 96.4% of respondents cannot rate daily CO2, and 3.8% of them have never used for tracking tool before. This directly answers research question 1. Accessible tools simply don't exist for most people. On the solution side, however, 92.9% of respondents said that they want to track data too. 91.1% said that they would use a fully automated CO2 app. Two insights reshapes our design. 75% of respondents cite GPS privacy as the top concerns. Would restructure our onboarding architecture globally? 65.5% of respondents said that personalized suggestions would motivate them the most, which became a core feature. Our survey didn't just validate a local problem, it designed a scalable solutions. So, what's Green Day? Green Day is an AI-powered mobile app with one single goal: makes stable living effortless for anyone, anywhere. And the flow is simple. The user app and has 2 input channels. Transport, GPS, every commute in the background. And for energy and process, one for bill receives and reads it. No manual input ever. And channel feeds our AI carbon engine using regional emissions coefficients. The output is a daily carbon score with personalized tips. And for every green action completed, the user earns point badges renewal in our green marketplace. And that's the universal habit loop.
Core features are a specific user need. AI carbon tracking, GPS and receive scanning deliver an accurate data CO2 breakdown by transport, energy, consumption in seconds. Personalized tip, the AI compare your footprints to regional averages and gives specific actionable suggestions. For example, Vietnam, cycling for 2.5 kilometers instead of riding your motorbike can save up to 0.9 kilograms of CO2 per day, which is nearly $46 in fuel costs each month. Gamification engine badges from bronze to Eco Hero. 54.5% of respondents said that voucher rewards would motivate them, and this feature was built from that exact finding. marketplace, a closed loop. Behaviors on points, purchases, further reduce your footprint. Using baseline, EBITDA emissions are 3.69 tons, and the IPCC finding that real-time feedback produces a 50% of annual reductions, with 10% as our conservative baseline. 10,000 users, Green Day saves 3,690 tons of CO2 per year, equivalent to removing 800 cars on the road. At 100,000 users, that becomes 36,900 tons, removing 8,000 cars. 40 inside shape of design. A survey validated features as a differentiator, a behavior-first architecture, and the blue ocean strategy. No competitor currently combines all of our features. However, we're also honest about our limitations. Our survey underrepresents the 15 to 10 group at only 17%. And our business model projections are still theoretical. And our AI model is just tested on only 20 invoices. More training data is needed. Future direction includes a user survey, food carbon tracking, grocery receipt, and a corporate ESG model, and finally, some school leaderboard challenges.
Across the globe, there's a gap between caring about the environment and actual behavior. Green Day is the bridge. Every small action today leads to a more stable future tomorrow. Thank you for listening.
All teams for session 1 have their presentation. Now it's time for comments and feedback. Please welcome Dr. Hai Chu Li.
Okay, thank you so much for your presentation on the 11 groups. And I deeply admire your presentation because the highly performance of your academic presentation are very excellent. Even this is a students, high school students conference, but your very good presentation make feel see in the professor's conference. So I'm part of all of your presentation. And you know that, for example, the topic you choose are fully matched with the sustainable development goals and all the hypotheses. You set up all based on a theoretical model. That's very good. And you just all of your group either you do your own experiment to show us the evidence you like to find the further research hypothesis. And you will design a survey to find the evidence to show your hypothesis, research hypothesis. That's very good. So I would like to encourage you, because we know that how to make the sustainable in our life is very important due to climate change. So I mean, even you are a senior high school, after you enter the university, also to make your efforts like today you did. You have to try to find the problem to solve the SDG problem, and you just keep the efforts to find the problem or find on the basis try to do the research to solve any sustainable development goals problem. Okay, so your presentation very good. And then the second thing I would like to share with you, I mean, today all the students come from the eight different countries. So I mean, it's not so. I mean, it's very good to have opportunity to know many international students. And I think very important to build up the good international friendship. Okay, so maybe following still have like 2.5 days. So try to make more friends from the other countries. Will be very good for your future. Okay, thank you so much.
Thank you, Professor Tai. So now we will be having a lunch break shortly. Our staff will go to the dining areas. And let me repeat this again. This venue will remain open for conference preparation. The conference will resume at 1:30 this afternoon. 1:30 this afternoon. So please be aware that there will be 3 presentation venues for international group this afternoon. After the lunch break, please follow the staff to your designated venue for this afternoon session. You can also find the information on this team's file holder. Lunch, please pay attention to the following announcement. Teachers of the international group, please enjoy your lunch at the exhibition hall in the Phoenix Box Cafe. Teachers of the international group, please enjoy your lunch at the exhibition hall in Phoenix Box Cafe. So please take a look at the staff who are waving hands beside the entrance. Teachers, the international group, would you please follow them? Those staff who are waving